great to see you again. I must be new to you all. I'm Angelo, your villager guide for today. Seems like you've been doing the rough work of collecting materials and surviving on the island. All of you did an excellent job on excelling using arithmetic and comparison operators, cell referencing, using and, or, not, and if, conditional formatting, and sorting and filtering. With the materials and tools you've gathered, we can now start fixing the ship for the way home. Don't worry, as the villagers and I will help and teach you along the way. Firstly, this is a pretty big dataset you've gathered, and we're gonna have to pick just the right stuff that we need so we can work on the ship repairs properly. To select and view just the items or data that we need from a large dataset like this, pivot tables will be a handy tool to use. Hello! So today, we'll be talking about pivot tables. But first, let's check out this dataset. So it's a pretty big dataset, and for us to better make sense of it, we're gonna learn about pivot tables. So what is a pivot table? Pivot table, like something like here, are tables that have shifted their rows and columns in order to easily summarize selected data from a dataset. Essentially, pivot tables make summarizing and presenting select data easier. So this is an example of a pivot table from our dataset, and it showcases the sum of total orders, so, as you can see here, from Melbourne and Sydney. So those are the cities, and there are our row labels based on the order dates, which are specified right here by the years, quarters, and months. So these are our column labels, and they make up this pivot table out of the dataset that we have here. So let's try making a pivot table ourselves. So to create a pivot table, first go to the Insert tab and click here. So you just select a table or range, and you can also choose to put it in a new worksheet or an existing worksheet. Then, when you click OK, there you have your own pivot table, but it's still empty. So you can choose which specific data you want to present. So the building blocks of the pivot table are called fields, right here. So these are the column headers from our dataset. These fields can be dragged down to these four columns or areas, namely the filters, columns, rows, and values. So these areas are what makes up the pivot table. You can drag the fields down to the area you want, or right-click them. And here are the options right beside it. So you can move the fields to the areas that you want them to be in. So you can also use the check boxes right beside the fields. So right here, so we can click this, and there we go. We have the field city in our rows, and you can see that here in the pivot table. So let's say we're finding the sum of the order total for each year based on the city. So we already have the city in our rows. So for our columns then, we will be using order date. So we can also drag and drop them into the columns. So here are our column labels, the order date. So we still have something lacking, and it's very important. And they are our values, the cells inside the table. So we can drag, or as I said earlier, right click the total, then click add to values. Then there we have the summation of the totals based on the year and the city. So there we already have our pivot table. So you could also change how the fields in the values area are summarized by clicking the field, then going to the value field settings right here. So you can change the custom name and also change how the values are summarized. So they can be summarized values by sum, count, average, max, and other statistical functions. Or you can also use them show values as. So that will just show the values as is. So we can have no calculation, or show them as percentage of a grand total, percent of column total, and other percentages too. So if you want to be specific and say, just get the sum of total orders shipped through delivery truck only, then we can place the ship mode, which is right here, and drag them to the filters area. Now, something here appeared. So we can click this drop down button and choose which mode of shipping we will use to filter the values inside our pivot table. So let's use delivery truck. There. Now it only shows the values in Melbourne in 2013 and only through delivery trucks. So this is the sum of total. You can also choose to select multiple items. So let's say delivery truck and express air. So both of these have already filtered the pivot tables and adjusted the remaining values here. So another way of viewing things in the table is using the slicer. So you can go to the ribbon in Pivot Table Analyze, then click Insert Slicer. So you can choose which fields you want to use as filter. So let's say the shipping date and also the account manager. Then when I click OK, there appears the slicer. So the ship date and account manager. So basically slicers are just another form of filters. But these slicers are easier to use, as you can see when you click. It already filters the pivot table, and it's also interactive. So you don't have to go to this drop down or drag multiple fields into the filter area. So it's less hassle. So right here you can also clear everything, clear filters, or select multiple ones. Like let's say ship date, then in this ship date. So there, you can use multiple slicers at the same time. Also, you can make pivot charts out of your pivot tables. So pivot charts make easy visualizations of the pivot tables you have, and the summarized data in the pivot tables right here. So to make pivot charts, you go to Pivot Tables, Analyze, then click Pivot Chart. So you have the same broad options as in creating normal charts. So you have the column charts, the line charts, pie charts. So right here, let's try making a column chart. So there we have our pivot chart based on the pivot table right here. So it also has the same filters and rows and years based on the pivot table. You can also sort and filter them separately right here. So you really have a lot of flexibility in using the pivot tables and the pivot charts in showing what data you really want based on your conditions or restrictions. So you can also add chart elements right here. So axis tiles, chart tiles, and it also shows you what the adjustment will be when you hover over them. And you can also change the styles and color right here. So you really have a lot of flexibility in using and editing pivot tables and pivot charts. So the other drop downs right here, the row labels and the column labels, have their own sort and filtering functions too. So say you just want the year 2014. So it will only show the data in the year 2014. So right here, the plus signs in these column labels is because of the multiple fields that we have in the columns area. So right here at the columns area, you can see years, quarters, and order date from the top to the bottom. Now, when you click this plus sign right here, it will expand into the next layer. And if you click it again, it will expand further into this next layer, which are the months. So here are the years, quarters, and months. So just note that the order of the layers of the fields affect the columns right here and how they are shown. So let's say I switch up the years and quarters. So I put it down here. So you can see here in the pivot table that the quarter moved up and the year moved down. So just take note if you're going to stack the fields into one area. So I can move it back by left clicking. Then I have these selections of options and move up. Then there we go. It's back to normal again. So finally, if you want to remove fields to edit your pivot table further, you can just drag them outside. Say I want to remove ship mode from my filters, so I'll just drag them outside. Or you can also click, then choose remove field. So there we go. Customization of your pivot tables is really flexible and easy. So let's put them back. Write them here, then write them back here. So overall, pivot tables are pretty neat if you want to quickly summarize or present selective data from a large dataset. And if you have a wide range of options on how you want to present your data or summarize them, pivot tables are the go-to tool to use. Now that we know what pivot tables are and how to use them, the ship repairs will be done in no time. For the next task, we'll be getting help from another villager to teach us how to efficiently find the specific details of an item or person in a large dataset.
Hi there, recruit. I'm Tom, and I've been overseeing the repair of our ship. Speaking of it, the ship is almost prepared for us to sail home, so we should begin thinking about boarding people. I'll warn you though, I've got word that some pirates on the island might try to sneak into our ship and take it over once at sea. We obviously can't let that happen. How can we tell apart our fellow survivors from scurvy pirates? Maybe we could look up their tickets using Vlookup and index match. If their tickets are in the database, we can verify if they're real passengers. Let's hurry before night falls. Yo! Hello there. Greetings. Salutation. I am here today to talk to you about Excel. So, if you're here, I'm assuming that you've gone through the last lecture, which would be pivot tables with our friend Angela. So in this video, I want to explore an Excel solution to a simple problem. Given one variable, such as order number, I want to find the following information along the same row: address, price, quantity, and total. So if you don't know what I'm talking about, based on the last video, we have this huge data set. Okay, it looks overwhelming. There's a lot of data. There's an order date, customer name, address, and don't worry what this data actually represents. It's mostly just dummy data. But what you can observe about this data is they each have unique order numbers. Imagine like your online orders. Each of them has a tracking number, and each tracking number has information about you associated with it. So there's customer name, address, city, state, and based on one order number, I can get the specific address of that order, the name of the person who ordered it, product they ordered, etc. So using Excel, I want to get the address, price, quantity, and total of any given order number. Alright, so we have two solutions to accomplish this: Vlookup and index match, and I'll go over each one. So as you can see here, I already have an order number and there's an address here. So how would I do that? So I have a little cheat sheet here, but if you will look at this cell, this is the code I used for it: equals Vlookup, and a lot of things here, but we'll break it down. So first of all, like I mentioned a while ago, each data point or each row has a unique order number. So Vlookup begins the argument, equals Vlookup, begins the argument of what value are you looking up. So in my case, it would be 50711, or in this case, it would be cell, it looks weird because it's merged, but it would be E11, okay, right? Well, in this case, it would be quotation marks. Oops, 1, right? Next is, what is your table array? Now, what does that mean? Table array is said here, dataset, exclamation point, A2 to 1, W 1040. Now that's pretty big, but what it is just go to dataset, go here, and I select this entire block of data. This would be your table array. So given this value, I want to find the exact data within this array, right? So, but how does it do that now? Goes Vlookup again. So we have our lookup value, we have our table array, and it's asking for a column index number. Alright, so column index number does is, let's observe in this array address, which column does your address belong to? So if this column A, B, C, D, just translate this numerically, this would be column 1, column 2, column 3, and, well, column 4. So what it does is, given your lookup value, it will search based on whatever is in the first column. So given lookup value 5071-1, I want to find within this entire array, the entire table, whatever cell data is in column 4. Okay? Sorry. So how can I test if this works for all addresses? Let's grab a random one. I'm just gonna copy this and put it in the index match, paste it over here. And supposedly it's 3248 King Street, Newton. And just to validate whether that is correct, it is. Hey, 3248 King Street, Newton. So it's pretty correct. Price quantity would just be, so what does that look like? Arguments are the same. Oh. But as you can see here, well, all that's changed is the column index number, which is 17. Now, why did I leave this note here? For a second, honestly, I forgot. But to explain, in principle, what Vlookup does, it pincers your column and row to find the data within. Alright? So given the row in which this data is found, again, you don't have to specify that I want you to match this with the first column, because that's what Vlookup already does. Given what given this data, I want you to match with the first column the row where this data can be found. So it says, this is row 60. Well, at least in terms of the data set, because you have your headers in row 1. So given row 60, I will find row 60, column 17. Alright, and it just goes, right, here's the row, and here's your column. And just outputs this tiny piece of data, right? And if we want to finish the job with what it's being asked for, we just do equals vlookup dataset this 23 false. Oh, you might be wondering, what is the false, true or false for? If you look at the formula here, it says that the last one specifies your range lookup. Now this just covers Boolean values true or false, whether or not to give an approximate or an exact match. What does that mean? If I say false, an exact match, it will, if I put 6091-1, it will only match if the data is exactly 6091-1. If I do an approximate match, which could be for numbers that may appear as decimals or floats, but in your dataset appear as whole integers, you may want to use approximate to round it down to whatever data is closest to what you find. So false is if there's no match at all, it won't find anything. But otherwise, it will look for whatever you specify exactly. But if it's true, then it will find whatever is closest to that data. So if you have here something like 5, like the number 5, sorry, has to be all caps, true, but here like 5, 7, 8, 9, -1. While it may actually have a value, if that's true, then it will give that because it's the closest. If it exists, then technically it is the closest. But if it does not exist, it will look for it. Something not exactly it, but as close as possible. But if I specify false, it removes beyond the shadow of a doubt that you will only get what you specify, right? So in most cases you will use false, unless the nature of your data is just that it can be approximated, then you use true, right? So it looks like this tool was able to accomplish our goal pretty well already. So why do we need another tool, index match? So here in principle I will demonstrate on a much simpler and smaller data set. This one right here. So I have 5 rows, 3 columns, just describing planet names, their diameter, and how many moons they have. And I just got this all off Google. I don't know these off the top of my head. So given a planet named Mars, I want to know its diameter, and later on, yeah, let's just start with the diameter. So first, I would just like to explain that index match and VLOOKUP in principle do the same thing. It's pincering a column and row. What makes index match sometimes used over VLOOKUP though is it removes the assumption that I am comparing the first row. VLOOKUP, without any specification, will always look for whatever data you specify in the first row of the array. So if I choose array A2 to, again, W1040, then even if I would like to search my data, say based on address, it will not find it in column A because that's the entire data set I chose. You can do that though in index match. So index match is not actually one function, it's the combination of 2 functions. So what does index function do? So notice this function equals index, sorry I'm saying a lot, but I think it's easier to show you in principle, equals index array, row number, column number. Alright, so given array, B23 to D27. That is my entire array. Mars, just by looking at the dataset, exists where? In column 1, right? And, oh no, sorry. What am I looking for here? The diameter of Mercury. So, diameter of Mercury is actually equals row 1, so this is 1, column 2, right? So instead of specifying Mercury for now, I just look at it because it's simple and say, row 1, column 2, that's where my data is. What match does is given name, let's say for this one, let's change this again just to be simple to Mercury equals match, oops, I made this all white, I forgot, equals match, what does it ask for? It asks for, like in Vlookup, a lookup value, a lookup array, and a match type. Alright, so lookup value is whatever is in this cell here, E22, which is Mercury. And my lookup array is this entire thing, right? And the match type, again, is, well, in this case it's 0 or 1 instead of true or false, but same principle. If it's 0, it's an exact approximation. If it's 1, it's true, which is if it's 0, then it's the exact match. If it's 1, it's an approximate match. Okay, I just combined the two. There's no such thing as an exact approximation. Unless there is, and I'm just wrong. Right? But the output of... Sorry, I need to change this just for continuity's sake. Okay. So, equals match Mercury within this array is equal to 1. And notice that the matching array here is not anymore the entire dataset, it's just the column I want, right? And the output is 1. Why is the output 1? Because it tells me that given this column, Mercury exists in the first row. Now, given what I said a while ago about pincering and the fact that index and match are actually two functions that you combine, maybe you have some idea about how to combine it. If you want to think about it for a second, which you can if you feel competitive that way, but I can also just show you. So, this function here is just a combination of everything. So if I change my planet name, this data changes, right? Almost the same thing as the address. So the function here is equals index your array, again, your entire array, and then here where it asks for, what does it ask for? Your row number, you use the match function to find your row number, right? So equals match F29, match whatever is here in F29 to the column planet, right? Get an exact match with 0. I'm sorry, that's my dog trying to dig a hole in front of me. But going back, match, and what is the output of this match function? Match F29 to this column, an exact match will just output you 2, right? Because it is row number 2. And then your column number, as you specify you want diameter, will be 2. So all the function is saying is get me whatever is within row 2, column 2 of this array. And it finds it. Now why most people use this over Vlookup is because I can see by changing the formula, I can actually change my column that I'm looking for. I can choose this, right? Get an exact match, and I want to know the number of moons. And given this, I can see that the planet, I don't know why you do this, but the planet has a diameter of 6,792 kilometers, has 2 moons. And I can do this while selecting the entire dataset. Or I can even go backwards, right? I want to find the first column. What is the planet that has 6,792 kilometers of diameter? So just like flipping the question, right? It's Mars. It would be harder. So the solution to the first query, given your diameter, how many moons do I have? To answer that question with Vlookup, you just go, I just select this as my array and leave this out. Perfectly valid if you want to just answer that question. But if I want to do the opposite, given this column, I can find what planet name it is. That's harder to do with Vlookup. And if you really just don't want to learn index match, you can just say, I can cut this and then paste this here and then delete this column and bam, my problem solved. I can use Vlookup. Yeah, you can do that, but index match is also just easier. So how do we use index match given the original big dataset? So as you can see, I'm still matching this original thing E11, and I'm actually looking for, what is column 5? Your city. So given your order number, what city do you belong to? And just to check that it works, this one says her city is in Sydney. No wait, I'm pretty sure it already said Sydney. Try someone who lives in Melbourne. Okay. Alveratoch. Okay. And if I change this, bam, she lives in Melbourne. And that's correct. So, just to recap, today we've learned Vlookup and index match. What both functions allow you to do is, given a specific piece of data, match and find something on the same row that you're looking for by specifying what column it belongs to. So if you get lost with that analogy, just think pincer, right? Given row X and specified column Y, just find whatever is inside row 2, column 3, right? And what Vlookup and index match allows you to do is, instead of giving me the numbers, just tell me what data's in that row and column. So yeah, that's basically how it works. And to give you practical examples, a lot of orgs would use this in, say, trackers and signups. If I as an org already know your ID number in my database, then logging into attendance, for example, well, before in like IRL registrations, you just like put in your ID number. I don't know what ID numbers look like now, but like say 145552. One of you has these, then I don't know. I don't think you guys have this as an ID number, but then it would just output like your name, your age, your gender, etc. And you can just like verify that like, hey, that's me. and you can zip in through. And they can like verify that you are an actual student of the Ateneo and maybe an actual member of that org because you exist in their dataset, right? So that's one way it can be used, but with these simple functions, the sky's the limit really. So I hope you find some use for this and that you guys learned a lot. So good luck in your adventure. That worked great. We got everyone in safely and showed the pirates the power of Exo.